Okay, in the last video, which I will link down below because, unless I forget, I derived the electric field along the axis of a dipole if you're really far away. So there's two equations that we have here. The first you see here is the electric field due to these two charges. And you'll notice that there's a difference because one of them is a little bit further away. The negative charge is further away than the positive charge. So there is a difference. In the approximation that r is much greater than s, where r is the distance from the center of the dipole and s is the distance between the two charges, they're equal and opposite charges, then I can get this approximate form of the electric field in the x direction of k 2qs over r cubed. Now, so what I want to do is to make a graph of both of these expressions for a dipole and see how close they are. Okay, so we're going to go over here to trinket, and I'm going to go ahead and start typing some stuff. Let's see, we need our Coulomb constant. I need the value of the charge, and I'm just going to pick 5 nanocoulombs. So Q is 5 times 10 to the negative ninth. And then the separation S is going to be, I put it at 0.02 meters. I'm not sure if that's good. So I could go ahead and calculate the electric field. But I want to make a graph. So let's first make a graph of the actual real electric field. So I'm gonna make a graph label. T graph is a graph. Its x title is going to be distance. I should put that in. Let's just call this x. It's the x distance in meters. And the y title is going to be EX. It's the x component of the electric field, newtons per coulomb. Now let's make two graphs. I'll call this one FR for real, and that's going to be a G curve. And let's make it color equals color dot blue. And let's give it a label. Label equals exact electric field. Maybe that's too long, but that's fine. And then we'll say FA for approximation is a G curve. And it's going to be red. And it's going to have the label of approximate electric field. Okay. Now, I need to start off with a distance. So the two things are 2 meters apart, or 0.2 centimeters apart. So I need an x value. I'm just going to pick something that may or may not work. I'm going to pick 0.05 meters. And I also need the step size. How far am I going to move when I calculate the next electric field? So I'm going to say dx is 0.001. Now I'm going to move further away until x is equal as long as x is less than, let's say, 0.0. How about 0.1? Let's just see what happens. And so the first thing I'm going to do is calculate the exact electric field. So I have that equation. I'm just going to say x, let's call it E1x. It's going to be equal to k times q times 1 divided by x minus s over 2 squared. Wait a second. No. I need another parenthesis right there. There we go. No, not there. Okay. Minus 1 divided by x plus s over 2. S over 2 squared. Close parenthesis. I think that's right. Okay. And let's just plot that. So this is fr.plot. The x value is going to be x. The y value is going to be E1x. And then I need to increase x so that I can move up. X equals x plus dx. I think that might work. Let's name this electric dipole plot. Save. Run it. There's an error. G is not defined. Oh, G. Ha. Q. No. Q is not a function at or near, oh, Q times, okay. There we go. That looks good. Okay, that's the exact value. Now let's calculate the approximate value. So E2x is going to be equal to my equation, which is K times 2 times Q times S divided by x cubed. And let's plot that. FA dot plot x E2x x. Excellent. Check that out. I'm pretty happy. Okay, so this works. So you see here that as I get around, let's say 0.075 meters away, the two values, the two expressions are pretty much the same, and that's good. So if I'm, sufficiently far enough away, I can use a simpler form for the electric field due to a dipole instead of the exact form. However, when I get really close, I need to change that. And we could even start a little bit closer. Let's do this at 0.4, and you can see that they're even further apart. Let's see how close we can get. 0.3. Yeah, okay, so they're getting further and further apart. Down here, they're closer and closer together. But remember that approximate form 1 is only on the x-axis if it's in the same line along the axis of the dipoles. If you move off of that, it doesn't work. 2, it only works when you're further away. So it's an approximate value. But this is super useful when you can use this in a lot of situations. Okay, I'm going to stop there. Hopefully this was a good example of graphing for you and plotting functions. And I'll talk to you later.